Welcome everyone. In this video I will try something different. I will try the circuit bending. So as you can see, I have a very nice toy here on my desk, and this is a piano for children, but the video will be not for children. So what I try to do is that I will disassemble this tool or instrument by just unscrewing all the screws here, and I will try to modify the circuit to get some fancy sounds out of this thing. And first of all, I just want to see the default sounds. So here the cover says that we need 3 AA batteries, so 4.5 volts. So what I will do, I will drill a hole somewhere and use a DC jack for the power, so I can connect my instrument to this kind of power supply. And in this video I have absolutely no clue about what I'm doing, because I have never done this, and I haven't read too much about it, just a little bit, and I saw a few videos and I found this thing very interesting. So I try to share all the steps with you so we can learn this stuff basically together. So first of all, I will just get some drill and I will drill a hole somewhere and then just add the 4.5 volt power supply. So let's do that now. So for drilling these kind of cases or enclosures, I really recommend you to use some of these conical shaped drills, because then you can control the diameter of your hole very precisely. So what we have here is that I have this conical drill bit, which goes from 6 to 20 millimeters, and then I have this DC jack plug, the 2.1 millimeter. So either you measure this diameter, or you just go a little by little and just try to match the whole diameter with the diameter of this. So drill a little bit and then try it, drill, try, and then you will end up with the desired diameter. So I have to figure out where to put this, but I think it would make sense to first just open this, because I don't know where is the circuit board and so on. So I don't want to drill somewhere where I know that I cannot put this thing. So let's just unscrew all the screws first. So I remove this. So this is the circuit, and you see it's a huge chaos now, because none of these buttons are attached to this circuit board here. So they are just put on it. Maybe I should have opened this upside down. So first of all, we have some kind of LED that was in the other side of the enclosure. And then we have all these buttons. I think I just clean up this mess. So this is our circuit panel here, the on-off switch, and then this will be the connection to the power supply, as you can see. So positive is the red, of course, and the negative is the white. So what should we do here? What we should do here is to desolder these wires first. So for that I fire up my power supply for the soldering tool. So one cable is here, And another cable is here. So we have the power supply. So we can immediately try this by connecting it to a real power supply. So this was the minus, and this was the plus, and we will need 4.5 volts. So this was the intro music, and I guess all the rest of the thing that we need will be here. So I tried to unscrew this, but first I just remove the power supply and see what is on the other side. The problem with these circuits, as I could see it from others, that everything is so integrated now that it's really difficult to do anything with the circuits, but we will see. So this is all we have. Some capacitors and some resistors, all of them are SMD, and then this is basically the brain under this resin thing. So what we could do is we could turn this thing on and turn this thing on. So listen to this. So once again. So I just added some saliva to my finger and then pulling my fingers through this thing, through these components, which are some capacitors and resistors here. So I guess we can do something here, and we have a 47K resistor here and a 33.3K resistor here. So what I would do is I would use a potentiometer and connect it parallel to this 47K resistor and see what happens. But the problem is that this is very small, so I will need some small wires. So let's get some wires for this exercise. So this is very thin copper wire. As you can see, you can barely see it. I don't even know what is good background. So it's there. And then this is slightly thicker. And then this will be used for the power supply. So maybe we should try with this first and see if I can do this without burning the cable away and making any short circuits. It's quite difficult to see the wire with this background, even for me. So this is a 47K resistor that I want to modify, so I chose a 50K potentiometer, so that is quite close in the value. So we will see what happens. So let me solder these things first. So these two cables are attached now, more or less. I have to resolder this. So now it's a solid contact. So I will need an extra hand here. So I will use this tool. just to make everything more visible. So maybe something like this. And what I just want, I will try to solder this together. Hopefully will succeed. Okay, so this thing is in the circuit. So let's see what happens if I turn this on. Seems like nothing happens, so let's see what we can do. What else we can do? Oh, I see. So what I could do is I could connect this thing to another connection. So let me actually test this. So I desoldered this potentiometer from the 47K resistor, and I will put it somewhere else just to see if we can get some sounds out of this thing. So I will try with a lower value, maybe that will be more helpful. And I will also try a bit thicker wire just to help my soldering work a bit more. So one piece and another piece. First of all, let's check if this thing works. So the potentiometer itself should work, but it seems that the soldering was not hot enough to burn off the insulation from the wire. So therefore I cannot really get anything, at least here. So now I added some proper wires to the 5 kilo ohm potentiometer, so this should work. So now I try to solder these things to those connections, which will be a bit more challenge because of the size of the wires, but let's see. So let's see if we hear something different. This doesn't seem to help. So seems like I found another source of error. So for some reason these potentiometers that I was trying to use were not so good. I tried several, but this is another potentiometer. So let's just solder this wire and I show you something cool here. So we are still at this 47 kilo ohm resistor there. And I just try to add this wire on the other side, just to make some magic. So now it's soldered just a little bit. Let's turn this on. So I could increase the pitch or speed. And unfortunately, if I increase it too much, then it doesn't work. But now we know this. So this will be our initial modifier. I will try to make some nice solders here and get this 100 kilo ohm potentiometer there properly, because now this is just a huge mess. But yeah, so this part works. And then there is another potentiometer here which is 3.3 and I have no idea what that does. So let's just test it. Let's short it. It does pretty much nothing, so this is not so useful. So we will also need a switch, because I don't always want to have this pitch, so I can connect and disconnect the potentiometer by just switching it on and off. So basically just like happened now, I can connect and disconnect to the other side of the resistor here. So let's see. So now it's connected. Now it's disconnected. So the pitch is different. And I found another connection. So between the top, let's call it top of the 47K and the top of the 3.3K, there is another connection which can bring down the speed. So this is some vaporwave music. I think you could hear the aesthetics of this sound. So I will use another 100K potentiometer there, and that will be another switch as well, because we don't want it to be enabled all the time. So let's take some notes of this. So this will be just a very, very crappy demonstration. So we have this is the 47K right here. So that guy is here. And then there's another guy here, which is the 3.3K. So what we can do is we have a potentiometer here in between this. So yeah, let's show it like this. And this is a 100K potmeter. And then here, what we do is basically we have a potentiometer here. Another 100K. So this guy is responsible for the speed up process, and this guy here is the speed down. So speed up and speed down. Just to show it again, I just want to demonstrate it. I just clean up this mess a little bit. So now I messed this up. It's too high value. So this was the speed up, and now, so this was this connection here, and now I just do a connection between these 2 points. So it's basically this potentiometer still. So let's turn it off and turn it on. And we got the vaporwave sound. So that will be another connection. So we will need 2 potentiometers and 2 switches for this purpose. And let's try to discover something else. This is wrong. So this is the same. And this is also the same. So I don't know if this goes to the ground or goes to the high within this circuit. It is possibly the ground. But these 3 things here are connected together, and then if I connect the potentiometer to any of these, then that decreases the speed. But then if I connect the potentiometer between the bottom here, so let's show it again. So this increases the pitch. But it seems like it only works through the resistor, so that is directly related to the resistor's value, because I'm just now connecting something parallel to the resistor, as you can see it here. So in that case, we are just changing the overall value of this parallel connection. But it doesn't do anything with the other. And it also does the same with this capacitor. So that is like interconnected with this thing. Because of the drawing, it's a bit hard to see what is happening there. But now I got another idea, so I will bring some new parts. So let's see what we can do with some capacitors. So first of all, because there are some capacitors there, so what if we change the capacity? So I have no clue at all, but these are luckily not polarized, so it doesn't matter if it's plus or minus. So I will just poke this into the circuit by basically shorting something with the capacitor. See what happens. Nothing really happens. Maybe add some distortion. What I would try is something else. Okay, so I could not find any other modification, but maybe we will have some more sounds if I connect everything back and I connect these as well. So what I mean is that if we use other sounds like these flowers, frogs and whatever we have in here, like this bunny, then I guess their sound will be also distorted by this. So for this, let's just add these two switches and let's just add these two potentiometers. So one potentiometer, again, one will be just modifying the overall value of this, but another will be shorting these two together and through some certain circuit here. So yeah, let me figure these things out, where to put the different connections. But I think the power supply will be connected somewhere here, but on the top cover, and then I will put the potentiometers here because there is a lot of space here, and I will put the switches next to them. So now first I just make the connections for these, or the holes, and then I will solder them once I figured out where the cables should go. So just to show the progress, I actually don't want to struggle with these now because I have to cut some nice square holes for this. So instead of that, I decided to use some momentary switches. So we have the two potentiometers here, as you can see. So this will belong to this, to the top, and this will belong to the bottom as well. And luckily I have some caps, so at least I can differentiate them by colors. And also what I want to say is that maybe this is a better solution, because while I keep this pressed, I will short the circuit through the let's say effects, so through the potentiometers, but when it is released, then these are neglected from the perspective of, or from this thing's point of view. So that's very nice. And then just to simplify everything, so if you see that the power supply box or the battery box is somewhere here, so the wire, this guy and this guy, goes from this area to this area. So if I put my jack here, that's a perfect spot because nothing is here. So I can put it there nicely. So probably I will cut a hole here and then just put this thing there. So the power supply will be also on the top here. So another thing that I will do is that we have the speaker cables here, and I will replace them with some thicker cables with more rigid, because I don't want to move this, but I will need these thin wires because it's much easier to handle them, and I want to bring these connections to my potentiometer and switch here by these cables. So I will just remove the speaker temporarily and then just replace the wires as well. So my achievement so far is not so significant, but I could do some small modifications on this circuit. So now, as you can see, this will be the power supply connector here instead of the three 1.5 volt batteries. And then on the top I will change the potentiometer to change the pitch upwards, and this is the temporary switch which turns it on. So as long as I keep this pressed on, then the effect will be applied, and the same applies on this black momentary switch. But then if I increase this potentiometer, so I turn it clockwise, then the pitch will go down, or the speed of the sound. So let's show it by turning it on. So this was the demo sound, and if I press the piano keys, just a regular sound. But if I apply the slowing pitch, you can hear. And also if I play some of these animals, so you could hear that I could modify the speed. Unfortunately, I was not able to get any glitches out of this, but I will keep discovering this circuit more. So, as you can hear, these are some beats built in. This might be interesting. Yeah, so the animal sounds, some of them sound very cool when it is slowed down. And then there are some songs. There should be some clapping sound, but this sounds also nice if it's slowed down. It's a really nice 8-bit sound. So basically this is all. If I want, I can change these to the different sounds. So for example, now this will be the piano, but if I press on the duck, then so maybe there can be something to be done here. Or yeah, so sometimes the circuit dies and then this LED goes on, so I have to reset it. So back to Rabbit. Yeah, and back to cat. It's a high frequency dog. It's the smaller the dog, the higher it sounds. So this is a very small dog. Done. Yeah, and then we have the songs, the individual songs for the animals, and yeah, the preset rhythms. I don't know. Yeah, but this is the first try, so it's not so bad. At least I could do some small modification, but unfortunately there are not so many elements on this PCB inside this box or enclosure, so I could not discover too many things. But I will keep searching for these kind of instruments and also keep trying with this, because it seems to be very interesting stuff to do. So you can get some weird sounds and effects. So yeah, so this was something unusual, but I wanted to try this, and why not share it with you. So I hope you liked it, you learned something. Unfortunately, I cannot really help you with these kind of things, because I just started it when I recorded this video. So this was something that I wanted to try as some new thing. So I hope that you enjoyed it or found it interesting, and see you in the next video.